Right. Thank you so much, Sumit, and thank you everyone for being here. As Sumit said, my talk will be on the cognitive mechanisms that power learning and creativity. And I'd also like to thank my collaborators, Aishni and Sumit, who've helped me a lot in this whole creativity and AI space. So just a little bit about myself, so my background. So my background is from engineering. And I got really interested in this whole space of creativity when my kids were growing up. So that's, when my daughter was in elementary school, pretty young, she got interested in this after-school program. It's called Destination Imagination. I don't know if you've heard about this, but it's a creative problem-solving program. So the idea is that these kids are given challenges that they work on for several months, and they have to come up with really creative and innovative solutions for the challenge, for their theme. And as a coach, I can't give them any ideas directly. So I can help the team build some skills. I can maybe nudge them in the right direction or help them think in different ways. But obviously, I can't give them the ideas. So as I started working with these kids over several years, I started to notice that they don't really think very creatively. They, they tend to think in sort of, I've found as like two different sort of ways. The first one is what I call a temporal locality. So if there is anything that's going around, in that time frame, like it's the Christmas time or Thanksgiving, all their ideas are going to be around toys and Santa and turkey or whatever. And then if you ask them, can you come up with some other ideas, they'll look around the room. If they see a picture of a bunny, they'll incorporate the bunny in the story. So if you think about all the different kinds of ideas that could be used to solve a challenge, they're really only focusing on these two different dimensions. So then I started digging into, okay, how do I get them to think in more diverse ways? And I started looking at different kinds of techniques that people have used, and there's tons of stuff out there. So I started creating some games and activities and brain teasers for them to think in more different ways. And then as I started looking at some more research, I came across studies that show that creativity scores among students, at least, has been declining steadily since the actually significantly. It's not even as steady anymore. He came. She was the first one to document this trend. And when she came out, this study became really, really, made a big splash in media, and Newsweek had a huge article about the creativity crisis. And one of the things that she found was that the decline has been across all the many different measures of creativity. So there's originality, like how many ideas that are very different are you able to come up with original ideas. Fluency, which is the number of ideas that you can come up with. Elaboration. Elaboration is about how do you, can you think, for the same idea, can you think in more detail? Can you look at different aspects? And that's also related to creativity, because if you can find issues in your idea, you can then start to build better ideas, right? If you find there are problems in this direction, you'll fix it and then move on. And then she also creative strengths. So there's a separate set of things about just sort of the personality traits or whatever you call them that are also declining. So children are less emotionally expressive, less verbally expressive, less willing to look at different perspectives, less humorous. So, and then she did a follow-up study, I think 2017 or 2018, and then found that this trend has actually accelerated even more. So obviously this is a pretty concerning thing, and that really motivated me to do more in this space. And I also want to share that some of these things aren't just limited to students, but also adults.
Yeah. Is this international or just in America?
So this study was at the US, so definitely it's the US, but there are other studies around thinking skills that have also shown decline in other areas, in other parts of the world as well. All right, so so here's a rough outline, yeah?
How long have they been doing those measures?
Sorry, could you repeat that again?
How long have they been measuring those?
Oh, they have been measuring for several decades now.
But more than before 1990, right?
Yeah.
Is there a reason?
Reason for the decline, or? So it's there are 3 or 4 different things that people think have attributed to the decline. The first one is children just have less structured time. So the amount of free, unstructured time that you get to just randomly think about things, or even get bored. When you're bored, you're thinking about different things and making connections. So that's declined. So children now between before 1990 or till now, whatever, have lost about like 14 hours per week of this unstructured time. Technology is another aspect. So when you're overusing technology, it takes away some of your, in some cases, it takes away your creative thinking abilities. And then teaching to the test. So schools are also getting very focused on preparing for a test, not giving enough time for exploration of concepts and things. So the outline is, I'll talk a little bit about what exactly is creativity, and then some of the techniques for creative thinking that seem to work really well. I've worked with kids for many years, and they really help improve the number and quality of ideas. Then I'll talk a little bit about the experiment we did with making AI more creative, teaching the same technique that we're using with kids to improve AI. And then finally, can we use AI to make humans more creative? I think that would be an interesting aspect to consider. Okay, so what is creativity? So most of the time, creativity is used very, very colloquially, and most people use it in the context of arts or crafts. But that's not the kind of creativity we're going to be talking about. So I'm focused more on this idea creativity, which is the ability to come up with ideas that are both novel and useful. So one of the psychologists, I think was one of the first ones to call this like originality into appropriateness. So if your idea is original, like nobody has done that before, but then it doesn't really solve any problem, or it doesn't even make sense in a particular context, then it's not appropriate, it's not useful. So then it's basically not creative. Or the other way around, you can have something that solves a problem, it's useful, but it's been done before. So then again, it's not creative. So you need to have both these components for it to be considered creative. So here's an example. So this is our dog, Simba. And other than, I'm going to tell him a couple of things about him, other than a Labradoodle, this is one of his favorite spots in our living room. So he likes to sit on this couch. It's right, there's a patio door on the left of this image that leads to the backyard, and we have a doorbell that he rings whenever he needs to go out. So when we trained him, he's trained on that. So he knows these two things. He likes to sit on the couch. He rings the patio door bell to go outside. And so one day he was sitting on the couch. We were all sitting on the couch, so he didn't have a spot. And he wanted to sit there. He wanted to join us. But we didn't pay attention, so he was just there. But he found a really clever way to solve the problem. So what he did, he went and rang the patio door bell. So then one of us got up, and we went, and we opened the patio door, and then he just ran back and claimed that spot, right? So that was a pretty novel behavior that he had never displayed before, right? He's not done it before, it's novel. He solved a problem, so that was a creative exercise. So if you think about what was going on in his head, he has sort of like these rules that when I ring the bell, somebody gets up, right? And then he's also seen these associations. When somebody gets up, I get a spot to go on and claim that, sit on the couch. So in this particular case, just when you have these, the rule one, sort of the final state, and the second rule, initial state, they're same or similar, and the neurons get fired around the same time, you can make a connection, right? Your brain automatically makes a connection, and sort of intelligent behavior emerges. Let's put it this way, right? So even animals are creative. They can display creative behaviors. So what is special about humans then? Right? So why are we more creative or whatever than animals? So here I'm going to use some of the work that Daniel Kahneman has done in the System 1, System 2. He really popularized those two concepts. And so the idea is that all of us all mammals, we have this huge associative network, right? All the concepts are connected to every other concept. That's where, I mean, dogs have the same thing. They're building these rules, they're building these connections between things, and so are we. But what we have that's different is that we have the ability to intentionally direct some of this work to the system one, right? So we can, so especially when you think about what we have in a system two, which is the working memory, in our working memory is think of this whole thing as like a simulator, right? We can take scenarios, we can run experiments in our head, we can literally simulate different scenarios, and for that we would need to query our associative, this network, see what we get, simulate those things, and then pick an option that makes sense. That's not something, as far as we know, that mammals can do that. So they end up displaying some of this behavior almost accidentally if the right situations happen and some of these neurons get fired and they get connected, great, some intelligent behavior can emerge. But we can really do this, do this process by directing attention to the right thing or doing the simulation. So in one way to think about it, this is that we can generate much higher levels of creativity in some sense by managing the system one. So think of it as prompt engineering for system one. So we tell system one what to do, and then it might give us, initially it might give us very predictable answers, but then we can do things and make it more creative. So here's a very, very quick experiment. So I just want you to, I'm going to give you a little prompt, and I just want you to think what comes pops up in your head, and just visualize that, right? So just think of an apple, like the apple as in the fruit apple. Did everybody get that? You can actually see it in your head. Now, just cut that apple in half. All did that? Okay, so show of hands. How many thought of a red apple? And then how many thought of cutting the apple, like if you think of the apple like this with the stem coming out, slicing it like this? Okay. But there are many different kinds of apples, right? There are green apples, golden apples, and you can cut them like this and see the star-shaped core. But we all tend to do very quick, what's the most dominant link? We're chasing that. And that's one of the things that Daniel Kahneman also talks about, that we can, if we kind of chase our dominant links, and that puts us in this, what he calls the associative rut, right? So we're going that. So a lot of the work that we're doing is basically making sure that you can snap out of that associative rut and explore other parts of your associative network. Okay, so the next part, I'm going to talk a little bit about the different kinds of techniques that can work pretty well in giving you very quick, novel ideas, give new insights in fairly short amounts of time. And these techniques, I've tried them with kids, adults, a lot of people, and they generally tend to lead to 2 or 3 times better and more creative ideas. So this is another very typical kind of challenge thing you might have all seen, right? So how many different ways can you use a particular object? And in this case, a leaf. So anybody wants to volunteer? How can you use a different way to use a leaf?
Smoke it.
Sorry?
Smoke it.
Smoke it, that's a good one.
Cover it with wax paper.
Very cool.
Toilet paper?
Toilet paper, yeah.
Tickle someone.
Rake it.
As a fan.
As a fan, very good, very good. All right, so here's an example by a 4th grader. So they came up with, use it as a paintbrush, use it as a quill, use the leaf to write or draw something on it, and roll it up and use it as a straw. Right, so if you look at it a little bit more carefully, you can see that 3 of these 4 ideas are somewhat related, right? They're related to the task of writing or drawing or something. And so this is basically they're displaying a little bit low flexibility. And flexibility means that you're not looking at many different categories of ideas. You're stuck on like one category, and then you're generating many ideas in that same category. So this is basically a little bit lower in flexibility. So one very interesting, very, very simple trick that you can do is to just ask, can you think of all the different kinds of leaves before you even start this exercise, right? So before giving the divergent thinking challenge, you ask them to think, and then they'll suddenly think of all the different kinds of leaves, right? There's the big cactus leaf, the banana leaves that are really big, cactus with the spikes, and pine needles, and all the other kinds of leaves. And then it starts to generate a lot more different kinds of ideas. So here's one of the ideas that she came up with, like a cactus leaf to make string art. And I couldn't get Gemini to do a better job in this, but you get the picture, right? It's using the string and make some interesting patterns. Banana leaf to make window shades, pine needles to make holes in paper. So you're starting to get a more diverse range of ideas.
So these suggestions came from a fourth grader?
Yeah.
Nice.
So here's another technique, which is, given a problem, you identify an assumption that you're making in the problem and just completely reverse it. So when you do that, you can get very, very interesting new ideas very quickly, right? So for example, if you have, when you think of a table, you'll always think of a table with like a flat top and 4 legs. So what if you reverse that assumption? Like, I have a table that has no legs, but you have to make this creative, so you have to come up with a good design that is both one, novel, and it has to make sense. It has to be useful in some context. Does anybody want to try it? Any ideas on what you would do?
Yeah, the table which folds like one piece of hard material.
Oh, that's very cool. And yeah.
In the restaurant last night that various people went to, the tables didn't have legs.
That is true.
Yeah, it was just
a block of thing, right?
I
Yeah.
could take a tree trunk and I can cut the tree trunk off.
There you go.
I
Yeah.
can take a hat and I can put my sandwich on a hat and it's acting as a table. I mean, like a cowboy hat, right? I think the problem here is I feel that creativity has incentives, and we have a social incentive to do things quickly and to pick things that the majority have, and so like I'm the person sitting in this room, but I get all the answers wrong, right? And I sat there worrying whether I literally saw 3 colors of apples. I thought about cutting it 6 different ways, but there's incentives against me doing that, and so creativity may not be a matter of us provoking, but could it be incentives that are creating some of the
And you're right about that. So there is actually, in research, there is a dip that you see in creativity around the 4th or 6th grade. And that dip is attributed exactly what you said. So that's when your social, the peer pressure, you want to conform to everybody else. So you actually become less creative in that time period. But then it picks up again. And again, and you're right? It's, some of these kinds of things, it's like you do the socially acceptable things. But then having the ability to be creative when you want for the kinds of problems that you want to solve, I think that is the important piece there. Yeah, Samir.
So now with this discussion, I'm also thinking that one important application of creativity would also be to, or the techniques that you have would be to generate diverse kind of solutions, which might be important even in the genetic programming setting. And at least what I observed in my experiments was that the diffusion models tended to be generating more diverse solutions than transformer models.
what happens with evolutionary art too. It converges too early.
So, so in this case, and this is a challenge that I've given to some of the middle schoolers. So one of the middle school student came up with a table that's suspended by on the ceiling, and it makes sense because you can raise it and lower it whenever you want to, and when it's raised up, then you have plenty of space to do other things. So this was an idea by a student. So basically what we're doing when you're doing this reversing assumptions, if you look back at sort of the associative network conceptually, you're basically saying there is a whole set of solutions here that are related to this table that are all maybe that rely on that one assumption. So don't give me any of that stuff. Focus on your stuff. Give me ideas that are that don't have that assumption. So you're directing your attention away from the more predictable responses. And one of the things I actually found when I was working with students is that older kids at least get the concept of identifying. So if you give younger kids an assumption, they will reverse it, they'll do great. But if you ask them to identify an assumption themselves, they find a really hard time. whereas the older students are able to do that. And one hack, I guess, that I found was if I asked the younger students to just draw. So if you're thinking about a table, just draw a table. And then it just becomes more easy for them to then identify, oh, now I can just sort of remove something from what I drew or change how I drew it.
So
Yeah?
I just got a philosophical question.
Yeah.
Is a table without legs a table? Isn't it a board? I guess I'm just a little confused by that.
That's a very good point. I guess one way to think about it is you still want to use it as a table. That's one way to think about it, that I still want to functionally use it as a table. But again, in creativity, it sometimes doesn't matter, because you can go from one idea to another, and it might trigger and give you something completely different, and that's not the problem that you even thought about and started off with. But then, hey, you suddenly came up with something that's also useful in some context, and it's a novel idea, and it's fine. Like you created something. So, and the reason I think that happens because the visual spatial aspect of the working memory is not maybe as fully developed in younger kids, so it makes it easier when they can draw the thing and see that. So the third technique is associative thinking, where you're going to try and combine concepts in new ways. So the sort of the combinatorial type thing. So here's another challenge. Can you think and make an invention that combines a mug and a ball? Anyone? I'll give a minute. How would you combine a mug and a ball to make something new? Yep.
A juggling toy where you tie the ball to the handle of the mug and you throw it up in the air.
That's pretty cool. Anybody else? That was actually one of the responses that I think GPT-4 gave. I just need to remember.
What about?
Oh, he has one. Yeah. So I'm going to actually give you another tip. So instead of actually combining it directly, maybe take an attribute of one thing and then combine it to the other. You end up getting more sophisticated ideas. So in this case, we said, okay, let's try to, instead of combining a ball directly, we'll take the inflatable aspect of a ball and then combine it to a mug. And now you have an inflatable mug. And then you can make a case for maybe it's useful to take it on hiking trips. It can be packed more easily, and maybe the extra air in between can act as an insulation layer and keep things warm for long and things like that. So then that gives us better ideas. In fact, you can teach kids to do that also. So when kids are very, younger kids, they tend to directly combine. And as you grow older, then sometimes you start to get a little more sophisticated and you're taking an attribute. So in this case, this is by a second grader. And they're trying to make a notebook. And so his idea was he's going to combine it with a Kleenex. And his idea was that he should have a pouch for keeping Kleenex at the back of the notebook. And why? Because then if you're writing and if you need to blow your nose, then great, you have, problem solved. So that's the kind of response. And that's, again, it's creative, it's useful, it meets the bar. But older kids, sometimes you could spot that they start to use more attributes. And I'm not 100% sure, but I feel like if you can get them to think more from the attributes perspective, it somehow leads, as they grow older, into more analogical thinking. Because that's more, it's not about direct connection, it's about the relationships and attributes of different things and how they, how they relate to other things, yeah.
So circling back to the point of it being sort of a 2x or a 3x improvement,
Yeah.
So I could totally see how you would measure that in think of all the different ways that you can use this, you can count. How do you see if something is 2 times more sophisticated in this case?
Yeah, I don't think there's a good way to do that. So it's more of a subjective looking at a bunch of things, yeah. It's a good point. So what we're really doing with random association is you're almost like sort of firing up 2 different parts of your brain, like based on these 2 concepts. And eventually these concepts will somehow merge, like some paths, that they'll eventually lead to. And and then your brain is basically doing simulations on these different paths. And then and one of those things will win, and you'll find some new insight. That's sort of very high level conceptually speaking, that's what we're trying to do here. Okay, so I talked about like all these different kinds of techniques. I mean, few different techniques that have shown to improve creative output very quickly. So the next question we thought about is, can you actually teach AI to be creative, right? If you teach the same techniques that work for humans, would it actually help AI?
Quick question before you move on to that.
Yeah.
Were the effects lasting? I mean, you measured them, you had a setting, and you said, here are some things that will help you be more creative. And
Yeah.
so, they're more creative. But
I mean, the work
6
that
months later,
so
are they
in
more
that
creative?
specific, I have not done that stuff to measure the lasting effect, but there are research studies that show that. So if you've been, even if you do a creative training session for, like a whole session, I don't know if it's like an 8-week, 12-week or whatever, the effect of your thing lasts for at least like 6 months or so. And your brain literally reconfigures. So there's research that shows the people who are more creative, they have more white matter, so they're actually making more connections between different parts of the brain, and that just gets physically changed.
So if a child children lose their creativity and can regain it? I mean, like, so is this, can you go to a very creative preschool and kindergarten, and then all of a sudden, when you get into a structured school, will you lose your creativity?
Yeah, you can
Are
lose.
risk of losing it, or is creativity something that we sort of bake the neurons in early and then we get to?
No, I think you can keep building creativity. I think it's the easiest if when the kids are young and their brains are still, developing. So that's good. If they're practicing, they'll build the right kinds of things because your brain does prune things after some time. So if you're not using certain kinds of thinking, it'll remove that. So it might be harder as an adult to build up your creativity, but not impossible. Yeah, Sumit.
So there was this question on how to measure creativity.
Yeah.
Maybe you might want to share, one cool thing that I think, you or Aishni came up with was along the dimension of originality. So you searched whether that object existed on Amazon or not.
Yeah. I'll cover that soon in this one. So if you think about it, like we store all of our information associatively. So we have all these concepts connected to different concepts. But LLMs are also doing that. They're building associations between words. So our hypothesis was that the same technique should kind of work because you just wanted to like throw it off a little bit and make it think in a different dimension. So it's a limited form of associative network, but it should still work. So that was our hypothesis. So we said, we'll just try that one technique, just that associative, combining very random elements, and see what we get. So we picked 3 different domains. We picked product design. So in product design, we took very simple objects, like household objects, pencil, comb, coffee table, these kinds of things. And the reason is that, sometimes when you have more complicated things, it's very easy to come up with something if you just throw in all the electronics and things. So we wanted to keep it simple and actually see whether it's a creative idea or not. We also did storytelling. So we took fairy tales, and we wanted the ChatGPT to come up with a creative version. We had to do a little bit differently. What we did is for each of these stories, we already gave it a twist. So we gave it a little bit of creative this thing. And then the one version just did the story with a twist, and the other version did a story with a twist plus a random object that it had to do. And the reason for that is if you don't give that initial thing, it can create very different genres of stories for the same starting point that it's very hard to compare. And the third one is a marketing domain. So we asked it to make flyers, marketing flyers for different kinds of mom and pop stores, coffee shop, yoga studio, stationery store, and things. So these were the 3 domains. And the methodology, the prompting was fairly, at a high level, it's very similar. We're asking it to create a creative version of whatever domain it has, and that's the control version. And the random association version is where you have to incorporate a random element. So it just gets an extra prompt. And just like we did that activity before, we gave it a tip that instead of combining the object directly, you can even use attribute of the object. In the product design scenario, we also used an additional experiment that I'll explain next. And then finally, we had human annotators evaluate all the responses, except for the originality for product design. And for product design, we just kept a very high bar for originality. We said if it comes up with already knows all, it has a lot of information already. So if it came up with an object that we can't find on Amazon or Etsy or eBay or any of these sites, then we're going to consider it original. Otherwise, it doesn't get a point for originality.
So when you give it a tip, are you stating the attribute or are you just saying use an attribute?
We say use an attribute. So the one hop is inspired by a study that these guys did. And what they found is when you combine something that's completely unrelated in product, you can actually come up with some things that are kind of bizarre and don't make sense. So what you can do is you can reduce the randomness. So instead of going from your base object immediately to the next hop, which will not give you very original ideas, it'll be more predictable sort of ideas. If you sort of skip and jump over one of the first hop and go to the next one, and then try to combine, you get some more fresh, you get some novelty without it being very incongruous. So it tends to reduce that incongruity. So we decided to also include that, this algorithm in there. So how did we do? So we found that in terms of originality, for the random association, originality improved in all the domains: product design, storytelling, marketing. For the usefulness score, the product design didn't do as great. It was only 40% of those ideas were as compared to the 71 or 67 for the one hop. The storytelling did pretty well, and marketing was more or less similar to the control. So overall, it still actually produces more creative responses. I'm going to show one example, like for the product design. So it came up with a screw-inspired pencil, and the idea is that it features a spiral groove that you can use to like screw into the whole in a notebook cover or something, so you're not going to lose it. It's always there. So great idea. The picture doesn't kind of make as much sense because they put the groove in the part that gets sharpened. But the human annotators, we didn't give them the images. We just gave them the textual description because a lot of the images were very, very, they didn't make sense as much. It wasn't very good at image generation. But so they just looked at this stuff and they said, okay, that makes sense and it's a good idea. Here's an example from marketing. So this was, the goal was to create a marketing flyer for a stationery store. So this is the control version, and this is the one where it had to associate with a flower vase. Does anybody want to take, which one do you like? As a show of hands, do you think the first one is better or the second one? Second? Yeah, so I think that's what I think most the annotators also rated the second as the more creative one. For some reason, it actually creates a better, either the introduction of the random object, it obviously creates a new, a novel combination, but it also seemed to have created sort of a theme. So it's not putting too many of these random elements or into the image. It somehow made it a little bit more, it feels a little bit more intentional and less cluttered. And that's something we found in other images as well.
How did you design, did you give it the vase prompt?
Yeah.
Yeah, and how do you decide on that word?
Just randomly.
Like how?
Yeah, we had a bunch of objects that we just randomly gave into. Yeah. Okay, so at least with this one technique, we know that we can get AI to give us more creative ideas. And the last part, how much time do we have? Okay. In the last part, I just want to make a case for why I think it makes sense for us to leverage AI to make humans more creative. So earlier in the thing, I mentioned how creativity scores have been declining, right? So that was a study that came out in 2011 and made a big splash. But more recently, and this was a study that came out in 2023, so most recently, in the last 4 or 5 years, we're seeing a reverse Flynn effect. So for those who don't know what the Flynn effect is, since the 1930s, IQ scores have been growing steadily. So that was called, the psychologist who found this was, it was named after him, the Flynn effect. So IQ points, like I think 3 to 5 IQ points per decade. And that had shown a steady increase up until the 2000s. After the 2000s, more recently, we've started to see that the IQ scores have started to decline again. And that's called the reversal effect. And that's actually, somebody asked about it was actually first documented in Europe, and the US study came out more recently. So it's again more global. And one of the things that even the study points out is that the technology is a contributing factor. So there are a bunch of different tests in this particular test. Only one of them actually showed an improvement. Everything else, the letter series, the number series that we saw from Martha's, all of them have declined. Only the visual spatial increase, and that's maybe attributed to improved visuals. People are seeing a lot more visual data, and so that's the only thing that's actually improved.
That was done by age, though, as well, right? Your plot.
Yes, that one is also by age.
So it has children achieving lower scores all the time versus adults, and your education helps you be creative, or appears to be correlated.
To IQ, yes. Yeah, this is the IQ one. There's not creativity. So in general, I think the broad point is not just the creative thinking skills that are going down, but more recently it's all higher order thinking skills are going down. And that is a pretty concerning thing, especially when you think about that the technology has a fairly big part in here. So here's an example from another psychologist. The little story. So the psychologist Luria in the 1970s, he actually interviewed a bunch of rural Russians who had been sort of isolated, so they were not really in touch with the whole sort of, the scientific revolution. And this is a very funny example, right? So the interviewer asks this guy, there are no camels in Germany. The city of B is in Germany. Are there camels there or not? And the person replies, I don't know. I have never seen German villages. If B is a large city, there should be some camels there. Then the interviewer prompts again, but what if there aren't in all of Germany? And he says, if B is a village, there's probably no room for camels. So you can see that the villager, he's really rooted in the concrete and the physical, right? The whole concept of abstract reasoning is missing. And nowadays, I remember my son, when he was in first or second grade, they were doing these kinds of things in class, and it seemed pretty normal for everybody to do these things, right? So how did that happen? It has happened because it's, over the last few hundred years, our brains haven't physically evolved, right? Everything, so that's pretty much the same. So if you think from a hardware-software analogy, we've not had any hardware upgrade since then, right? All of it is the software. All of it is the training that goes into it. And as a society, we've done a pretty good job of having built those skills over so many years, right? So we have starting from, literally infant and toddler toys. They teach you to sort, categorize, do all these things. You've seen schools that teach a lot of these skills very early on. And that's how we've built up all this abstract reasoning skills. But it's a software layer in some sense. So if you don't train, if people don't get practice doing some of these things, it can also go away, which is what we've been seeing with some of these decline in thinking skills.
Do you, by that, do you mean that we're doing less of these things, that you've got fewer infant and toddler toys that?
Well, maybe not infant and toddler. So maybe it grows, and I don't know exactly the progression, maybe, but it maybe grows up a certain point, but definitely school, it's not doing as well. Again, the teaching to the test or whatever. So schools are perhaps not doing it. It comes, I don't know exactly which factor, and nobody will be able to point that out. But again, kids are spending too much time on technology. Maybe that also stops them from spending time thinking. They're not engaging in certain kinds of problems as much as they should be. Sorry. Yeah.
Do you have any information on the dispersion within population groups? Is it that kids in aggregate are getting 2 points less creative, but the top 20% of kids are just as creative as they ever?
That is a very interesting question. So I actually forgot to mention.
Society's also gotten wildly less equal in the last 35 years.
True, and it's going to be very hard to it's going to be very hard to figure out exactly what that is. But actually, should I mention this important thing? So the creativity scores that I pointed out earlier, where do you think they come from? They're actually used in school districts use them to identify gifted students. So it's basically students who are eligible or applying for the gifted and talented education parts of the program. Like the most school districts in the United States, they use the cognitive abilities, which is the IQ critical thinking type of thing. But once you've done that, they also make sure they do a creativity test. Not all school districts, but some of them do this creativity test, just to make sure that you at least cross a certain threshold. So it is skewed towards what we consider the tests are skewed towards the high achievers. So coming back to AI, I think like AI is, that's an important area for us to think about, is because AI, one, is going to be used a lot. It's already being used a lot, right? And so it is going to impact. With any technology that comes out, it's, we don't just use technology, we co-evolve with it, right? So in this case, AI is going to have an impact on how things happen. And this is a study that came out very recently. And this is from University of Pennsylvania, where they did a study on high schoolers for math. What they did is they tried to see, for some part of the curriculum, they created these study sessions. So they're doing the regular lecture and everything, and they had these study sessions. In those study sessions, they broke students into 3 groups. The one group got nothing. They're just doing practice problems. So they just had the course notes and the lecture notes. The other group got the base version of the GPT, so to help them with the problems. And the third group got the tutor mode, which was basically doesn't give answers very directly, and it gives useful feedback and things like that. So they found that in the short term, the improvement was pretty good. Like all the kids who were using AI in any form, they showed very quick performance improvements, 48% and 27% compared to the control. But then when it came time for the exam in the second phase, that's when the kids who were using any form of AI, they actually performed worse. So the base was 17% worse than the kids who had not used AI at all. And the tutor mode actually came out to be close to so it didn't really significantly harm or this thing, but it also had no effect. And so that, again, points to that we need to be much more careful about how we design our AI systems to really look at how it impacts student learning and student thinking. So recently I found out from Sumit that there's a group in Microsoft that actually is also looking at some of the same kind of problem. And I think, when I looked at the vision, I thought it was actually perfectly encapsulates what I was talking about. And it's talking about like how we are focusing on solving some of these very, very specific problems, how to make things more efficient and more productive and all of that stuff. But these systems are very powerful, and then there is definitely a risk that, that this approach may bring, harm human cognition in the long run. And so our goal should not be just on automation, but on augmentation, like imagining how AI can help people to think better. And I think I really think that's where we should be focusing on. So with that, almost at the end of my talk, so I just wanted, to share some of the ideas that I think that we can do, and I would love to have feedback and ideas from this community as well on how do we address this problem of improving AI to, make humans better, not worse. And one of the ways I think is that maybe if you have LLMs that can integrate some of these creative thinking, maybe in critical thinking, different kinds of thinking techniques that prompt humans so that they are engaged in the process, more of an interactive thing as opposed to a simple, like, I'll just solve this for you, don't worry about it. And so you keep building some of those thinking skills and creative and critical thinking. When it comes to education, I think there's other opportunities as well. You can create a lot more personalized, like educators have a hard time, sometimes, obviously we all know that, with creating very personalized lesson plans that incorporate different thinking styles. So creating a personalized teacher assistant that can help with creating those, that's really useful. Having a system that can allow teachers to collaborate better between different subject areas, again, integrating some of those cross concepts into cross-disciplinary projects so that kids are learning, they're being able to much more seamlessly connect different concepts with the same project that they're already learning. And then, of course, like improving hints that allow more desirable difficulties that can tie into better learning outcomes. So I think these are all things that I think should be achievable, that can improve some of these problems that we are facing. And so I think that's about it. Thank you very much.